And then your functions, remember, if it's going to be a function, it has to pass, did you all hear it called the pencil test or the vertical line test?
Vertical line.
Okay, I use vertical line test, but pencil test is the same. Basically what it means is your function has to actually be a function. So it can't be like a circle or anything like that. So let's say this is f of x. Okay, does that pass the vertical line test?
Yes.
Okay, now let's draw a straight line. Does that pass the vertical line test?
Yes.
Yes. Now, together, they don't. But remember, that's not the rule. Separately, they have to both be functions. Okay, when you do that, you're going to trap a region of area. Okay, so the way that you would find the area of that region is by integrating. Now, your boundaries are going to be the domain of that specific region. So let's say that this number is x equals a and this number is x equals b. Those would be my integral boundaries. So down here it said area, but then it got hole punched away. Okay, your area would be from a to b. And then do you remember we talked about on Monday and Tuesday you would do the top function minus the bottom function. So in this case, I'm going to label them with f and g. Okay, this would be f of x, this would be g of x. And so when I subtract in my integral, I do f of x first, g of x second. Then remember that your integral is going to come out positive if your area is above the x-axis. And then do y'all remember that it comes out negative when it's below the x-axis? Okay, so if you were to integrate underneath the x-axis, it would give you a negative answer. Okay? So, that being said, let's jump to your homework. Okay, and we'll maybe do numbers 10 and 11 unless we have a different question we need to look at. Are those okay? Alright, so let's skip to 10 and 11. We'll come back to these notes in just a second. Okay? Let's do number 10 first. Okay, so look at it. What does 3 cosine x look like? And actually, this is in the calculator section, so why don't y'all get out calculators? And then just graph them, because we could try to do it without, but if we're going to end up needing it anyway. Okay, graph both of those guys, and then sketch it onto your paper. Okay? You're typing in those equations into a calculator.
Do you have a calculator?
Anybody need one?
A long time. That's kind of close. Not close, but I can open.
You need one?
I think you can.
Okay, type them in, type them in.
That's all I've been using skin calculator. I don't like skin calculator because it's dirty. It looks the same, right?
You need one?
No, it's silver. It's black also. Black. Oh, yeah, black is silver.
Alright, so you're typing those in, and then I want you to sketch the graph onto your paper.
I still remember that stuff. That was a long time. That was like last year.
Okay, so y equals, ooh, look, wow, great. Look, I get to cheat. Okay, graph, boom, there it is. So I'm now going to sketch that onto my paper, yeah? Okay, so we have x and y axis. Then we have cosine here. And then we have a line here. Okay. Everybody looking at that on your calculator? Okay, let's try to shade the first part. So it says, I want to be enclosed by f and g and x equals 0. Is that vertical or horizontal? X equals 0. Okay, that would be vertical. And so that means that I'm going to start at x equals 0, which would be here, and I'm going to shade between those graphs. Now, let's talk about, which function is on top? Okay, so I'm going to call it f of x. Okay, but that is cosine. Okay, and then what's the function on the bottom of the region? The line, which is g of x. Now, where am I going to integrate from? I need to go from x equals 0 until wherever this is. Was that point given to you? Then you're going to have to find it. Do you know how to find it? Okay, set it equal. Very good. Or you could just, if it's on the calculator, find the intersection. Okay, so do that now. Second trace. Intersect is option 5. And then enter, enter, enter till you find where they cross. What'd y'all get? 5, 3, 6, 9. Okay, so ready for this first part? I'm going to find that area. So my area would be A equals integral from, what are my x's? What are my boundaries? 0 to 4.5369. 0 to 4.5369. And then where is my top border, we said? Which of the two, F or G?
No, F.
F on top. Cosine's on top, G is on bottom. And then how would you do that integral in your calculator? Not by hand, right? Okay, which we're going to just kind of skip for right now. Okay, go to part B. Exact same functions, but this time they want us to find the area bounded above by F and G and below by the x-axis. Okay, so I'm going to shade that in a different color. I want my functions on top, and I want the x-axis to be below. That would be this. You see the little orange section? Now, I'm going to blow that chunk of the graph up and make it bigger for part B so that we can graph on it, okay? So it's a line and then a curve. Okay, and I don't care about everything else. I'm zooming in on this part of my graph right here. Okay, pretend like that's zoomed in. This is my region right here. Is that a sandwich or a cusp? Okay, it's a cusp. Now, do we already know this value right here from before?
Yes.
What did we get?
4, 9, 5, 3, 6.
5, 3, 6, 9. Okay, what are the other 2 points that start and end my graph? The x what? The x intercepts, right? So I need to know what each of those are. Now, this is a straight line. Half of what minus 1 will give me 0? 2. If you're not sure, this is what you would have done. Half of x minus 1 equals 0. Add the 1 across. Half of x equals 1. And half of what is 1? 2. So that's this number right here. Another way you could have done it, what did you graph it on? Calculator. You could have found the intersection on here too, right? Okay, now for my second one, with all this cosine stuff going on, I'd do it in the calculator for sure. So let's do that one together. Second trace. If I want the x-intercept, which option am I going to pick?
0.
0. Okay, that's the same as an x-intercept. Now, when you pick this is important, okay, even if you know how to find these. Which function am I tracing right now? Cosine. If I wanted to trace the other one, remember you just arrow down and you could trace the line. Now, we want to trace cosine, but if you needed the other one, you'd have to go down, okay? So I'm going to push left bound, go to the other side of where they cross. I'm going to push right bound, and then it's going to tell me where it hits right here. This is 6.2831. And then when it is a cleft region, this is important, you have to split it into 2 integrals. So I'm going to integrate from here to here, and then I'm going to do that second chunk on its own. So this right here is going to be where I switch from one function to the other. Okay? So let's do just my green side first. What are my boundaries of integration from 2 until 4 point blah blah blah? Area equals 2 to 4.5369. And then for that section of the graph, which function am I touching? The line or the curve? The line. What's the equation for the line? That, or you could just call it g of x. Plus, so that's for this side. That's that area. On the other side, what are my x values that I'm between? Until 6.2831. And then for that chunk of the graph, which function am I touching? The f of x. Very good. Okay, does that make a little more sense? Okay, now, if the graphing and knowing where to shade is what confuses you, remember, the AP test most of the time will give you that graph. The only reason that I don't do that is because it would take me 100 years to make a single assignment. Okay, so if you are confused about where to shade, I wouldn't stress about that. If you can see the shaded area and know what to do, that's what I want you to be able to do. Okay, let's look at 11, please. The very next question. Okay, go ahead and type those regions into the calculator. So we'd have square root x minus 4, and then negative x minus 10 to the power of 3. Now, quick question. Just looking at the graph here, let's review some parent graph stuff. If there's a minus 4, which way does that shift your square root? To the right 4. So I'm going to go right here. This is 4, and then there's my square root. Now, a cubic function is a squiggle. The negative means it's going to squiggle downhill, but look at my graph. I can only see part of it. So I'm going to go to my window, and I'm going to make it go to 15 instead of only 10. So I'm going to make it go just a little bit farther to 15 so I can see the full squiggly shape. So look, it comes down, and then it curves across. So it goes like this. Now, pop quiz, if there's a minus 10 in the parentheses, which way did that shift? To the right, how many? 10. So this is 10 right here. You don't even have to find it on this one if you know your parent graph stuff. Okay? So now let's shade for part A. I want to be enclosed by F, G, and the x-axis. Well, if I want to stay above the x-axis, that would be here. Is that a sandwich, or is that a cusp? Cusp. How many integrals are you going to have to set up? 2. I know my x-intercepts. What point do I not have so far? You don't have where they cross, so go ahead and find that. Label it on your graph. Second trace 5. And I got it around 8. Is that what y'all have? Okay, so ready? I'm going to cut my graph up. This is going to be my side 1. This is going to be my side 2. For side 1, what are my borders? 4 to 8 point blah, blah, blah. 4 to 8.7055. And which function am I bordered by? The square root or the cubic?
Square root.
The square root. That's my f of x. Plus... Now I'm on my second side. That's this little chunk right here. What are my borders? What are my x's? 8 point blah, blah, blah till where? 10. And on that section of the graph, who are you touching? F or G? G, which is, you can either write out the expression or just call it G of x. If they already named it that, you're allowed to use that. Okay, does that make sense for that one? Okay, the other one for part B is a little bit tricky to shade, so I'm just going to do it for you. I want to stay between F and G from 7 to 10. So if this is 8, 7 would be over here, 10 is here. If I shade between my graphs, it would be that. Remember, if that's hard for you to understand, just remember they're going to graph that for you. So pretend like it was already graphed for you. I have one pocket here, and I have one pocket here. Now, for this first pocket, where did I start shading, it told me? Look at your interval. 7. And then where am I going to stop? 10. For my first side over here, I'm going to integrate from 7 to 8, point blah, 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 7055. But for this tiny part of the graph, who's on top? Because remember, I always have to do top minus bottom. Is it the square root or the cubic? So I'd have to do G minus F. So far, so good? Because who's on top for that part? G of X, right? Okay, plus. Now I'm going to my second side. That's this pocket right here, this second green pocket. What are my endpoints? 8 blah, blah, blah till 10. And who's on top for that chunk? Square root, which was F minus G. So the only reason you have to separate those is because the same function wasn't on top the whole time. Does that make sense?
Wait, do we have to add them instead of
Uh-huh. Well, you're subtracting in the middle, but you're adding the two areas together. So 8.7055 to 10 of F minus G dx. Okay? Do you feel any better about this now? Okay, but remember, if it's the graphing, I would say if you understand how to graph it when you have the picture, that's good. Okay, so what we're doing today should be easy if you understand that. So go back to your notes. For my people that were in pre-AP, I'm sure that you graphed functions with respect to y. If you were in regular, I think it depends who you had. So if you're graphing, change these to y's. Okay, it's super, super, super easy if you understand the x stuff. Okay, your functions, instead of being in y equals form, they're going to be in x equals form. So instead of it being like y equals x squared, it'll be x equals y squared. It's going to be flipped. Okay, instead of passing the vertical line test, they have to pass the horizontal line test. So we're going to draw some examples of that really quick down here. Let's say one of our equations is x equals y squared. Well, what shape is squared usually? It's a quadratic, but instead of opening up or down, it's going to open left or right. If it's a positive y squared, it's going to open that way. Okay, then let's say we have another one. Let's say it's x equals, I don't know, y plus 1. Well, what shape would that be? Would it be a curve? Be a straight line, right? So just draw it in like that. Okay, and then I'd have my two graphs. Okay? Now, does my first U that I drew, does it pass the horizontal line test? If I draw lines in, would they ever hit my U more than once? What about my line? Does it pass? Yeah. Now, do they have to pass together? No, but separately. Okay? So your integration boundaries are going to be a range. So when I set up my integral, I don't care about the x's they cross at. I'm going to care about these y values. So we're going to say this is y equals c. This is y equals d. So when I integrate, I'm going to use the y values of the pocket. Okay, and then when I do my area, I'm going to do the right function minus the left function. Now, if you don't know your right minus left, remember you do this. This one's the L for left. Okay, the other one's the right. So if I were to integrate this, area equals, it'd be the integral from C to D. And then which one was on the right for this particular graph? Was it the squared or the y plus 1? Y plus 1. So you do y plus 1 minus y squared dy. But you may not put x stuff into a dy integral, okay? And then if your area is on the right, it's going to be positive. And if your area is on the left side, it would come out negative. So think about it. It's like if you turned your head sideways, it's the same thing, okay? So this would have been my pocket. And I would do right minus left for my functions and then integrate between my y values. So let's do this one right here first, down here on the right. Okay, where are my y values, where those cross if I wanted to set up my integral? From where to where? Where's this y value? How low? 1, 2, 3. That would be my lower bound. And then what's my upper bound up here? 1, 2, 3. Okay, and then which is my function on the right? Is it the line or the curve? The line, and are they both in x equals form? Yeah, so it'd be 9 minus y squared dy. Questions about that? Okay, let's try the second one. First thing I want you to notice is that I can count my y values right off the bat. How low is this intersection? -2. Oops, that's not even a number. What is it? -2. Okay, and then what's that? Y equals 1. So when I set up my integral, it's going to be from -2 to 1, and then I'm going to run into a problem right here. What are my equations supposed to be in the form of? X equals, x equals, x equals. What's wrong with that one? Y equals, but we can fix it. Take your -2, scooch it over to the other side. What is it now? Y plus 2. And now I can use y plus 2 as that side. Now when I subtract left, right, who's on the right? Line or curve? Line minus curve. So it would be y plus 2 minus y squared
Oh wait, does that
dy.
matter?
Does the order matter? Yes. And this is why. If you integrate it backwards, you're going to get the right number, but it'll be negative instead of positive. Okay? Go ahead and turn the page, please. Okay, we're going to come back to some of these graphs. We're going to skip to number 1 on the second page, just to give y'all some graphing experience, okay? So, first question, looking at this, what shape is it going to be if it has a y squared in it? It's going to be a U shape. Now, parabola on its side. Now, it's either going to open to the right or to the left. If it's a negative y cubed, or y squared, which way do you guess is going to be negative, left or right?
Left.
To the left. So, go to 12, and then I want you to open it to the left. Now, I'm going to put a little note up here for you. It opens left because it's a negative y squared. If it had been a positive y squared, it would have opened the other way. Okay? The other thing that I want to be my border is the y-axis, which is the same as x equals 0. So this is going to be my other line right here. And do you see your region of area that you're trapping in there? This guy right here? Okay, now, all of the steps that we were doing before still apply here. How do I find where they cross one another? What do I do? Very good. I'm going to set them equal. So I want to find the intersections. So I'm going to set the x equals equations equal to each other. -3y squared plus 12 needs to equal 0. Okay, how could I solve that? What would I do first? Yeah, I'm just going to add that across to the other side. You could do it by factoring though. So now I have 12 equals positive 3y squared. What could I do next? Divide by 3. I added the y squared across, so my 12 didn't actually move. So divide by 3. 12 divided by 3 is 4. Then what? Square root. And then remember, I'm going to get 2 answers because how many times did they cross? 2 times. So this is going to be my -2. And this is going to be my +2. Okay? So let's set up our integral. Area equals integral from where to where? Bottom to top. What would come first? -2 until 2. And then which of my functions is on the right? The quadratic, which would be my -3y squared plus 12 minus 0 dy. Now question, do you have to put the -0? No, but if it helps you to see which one's which, then I might encourage you to put it. So this is the left border, this is the right border. Make sense? Okay, set up number 2 for me. It's still a quadratic, but if your 3y squared is positive this time, which way is it going to open?
To the right.
To the right. So I'm going to sketch my graph here. I'm going to start at +1, and I'm going to open this way. Then x equals 10 would be a vertical line. Draw it right here. And then what's the first thing that I need to find before I can really set up my integral? Intersections. How do you find the intersections? Set them equal to each other. Very good. So I'm going to take my x equals 3y squared plus 1. And I'm going to set that equal to 10 because this is x equals and this is x equals. So I just set them equal to each other. Okay, minus my 1 across. What's 10 minus 1? 9. Can I square root right now with that 3 in the front? No. So divide by 3. That means that y squared is 3, which means what are my solutions? Plus or minus root 3. And then remember, you know which one's which. The negative one's the bottom height. The positive one's the top height. So this is y equals negative root 3. Y equals positive root 3. Okay, then when I set up my integral, those are my boundaries. And then which function is on the right when I subtract? The line. So it would be x equals 10 minus x equals 3y squared plus 1. Okay, I'm going to write it and I'm going to make a mistake. Tell me what the mistake is. A equals integral negative root 3 to root 3 and then 10 minus 3y squared plus 1. Parentheses. That's the issue. Okay, when you subtract two functions, the one that you're subtracting, if it's multiple terms, you need to group it. I would say just always group it so you never mess up. Okay? Alright, so what I want you to do now is I want you to try to do number 3. Notice it's graphed for you. I'm going to come bring you a cookie for, I don't know, to help your spirit, okay? You're only doing region R right now. You should not need, actually just look at the graph. I'll just tell you. This is negative 1 because it's 2, 3, 4, 5. And then this is 1, 2, 3, 4, 5. That way you can just count. Okay? Want an inspiration cookie? Okay, you can do it. And then if you get that, I want you to make a guess for region S. Region S, just for a hint, is going to be a cuss. You're welcome. You need to talk to the packaging people for ordering. Roman? You're welcome. Roman? And remember, it's always right minus left when you set up your integral. You want a cookie? You want one? Okay, so now try to do S. Your R looks good. R is in S's. So you're going to have to break it up into two.
Is S all of it?
No, R is just the top pocket.
Okay.
And then S will be its own region. Roman?
4 would be a cusp. S would be a
Should we
cusp.
go one? You're
Do
welcome.
9.
Anthony, which one do you want, hun?
Wait, would it be 2 to,
Mara, which one do you want?
No, 2 to,
Right, press on
1.
Negative 1.
I think it's a negative 1 to 2.
Okay, where should my integral for R be from?
It could be the, no, region S. Yeah,
Negative 1 to 0.
Okay, area equals negative 1 to 6. Because look, where did they cross? At negative 1 and at 6, yeah? Okay, and then who's on the right? Is it this one or this one? Line or curve? Line minus curve. So it would have been y plus 10 minus y minus 2 squared dy. Did you get it? Hopefully? No. Okay, look at the second one. Look at region S. This is a cusp. For your cusp region, normally we cut it this way. How do you think we're going to cut it if we are doing it dy though? Instead of cutting it up and down, we're going to have to cut it right here. And so now look, this is going to be my side number 1. And then that top little chunk is going to be your side number 2. Okay, let's do area number 1 first. A equals. Okay, what are the boundaries from this height to this height? Negative, how many? 10 to negative 1. Because remember, you're using the range of that region.
Why do we do the bottom first?
Just bottom to top is how you would do it. So from negative 10 to negative 1, that would be this distance. And then what's on the right side of the curve? The line. So it'd be y plus 10. Now question, if I do right minus left, it would be y plus 10 minus, what is this? X equals 0. So do I have to write the 0? No. Can you write the 0 if it makes more sense? Sure. But this region, it would be y plus 10 minus 0 is your left boundary. Okay, now try to set up that top one. So it'd be y plus 10 minus 0 plus, where's my second integral going to be from? Negative 1 till 2. And what is my right side? Y minus 2 squared. And what is my left side? 0 dy. Does that make sense? Okay, so now flip back to that page that we skipped. And we're going to practice setting a couple of these up. Look at the bottom one first. Okay, are my equations in the correct form?
No.
No. Okay, so let's fix this top one. I want x by itself. Where does the minus 1 go?
The other side.
To the other side. So now it's a what? X equals y plus 1. And I'm not going to use the original equation they gave me because it was not in x equals form. Okay? So this is my new line. Okay, now for my curve, okay, my x is on the wrong side, so I'm going to bring my plus x over here. And what's going to happen with my y squared if it's on the wrong side? It's going to come over there, 3 minus y squared. So those are going to be the forms of the equations that I'm going to use when I consider my right and my left side. Remember, this is my curvy side, and then this is my straight line. Okay, now, how many pockets of area do I have? 1 or 2? 2. Let's do number 1 first. Okay, what am I integrating from for pocket number 1? What range?
2 to 1. Negative 2.
So my height is negative 2 until positive 1. And then for that pocket, for this bottom pocket, who's on the right side? Is it the line or the curve? So it'd be 3 minus y squared minus y plus 1 dy. That would be my first pocket. Pretend that weird parentheses in there. Okay, plus second integral. Now I need to do integral number 2 up here. What are my ranges? This is y equals 1 to y equals 2. And then for that second pocket, who's on the right side? Is it the line or the curve for this chunk? It would be the line, so it'd be y plus 1 minus,
Wouldn't it be add?
in the middle it's addition. You're adding those two areas. But, oops, I didn't realize you can't see that. Okay? Alright, let's do the one right above it. Okay, are your equations in the right form, or are you going to have to fix stuff? You're going to have to fix stuff. Look at this first one. Okay, y equals x squared. Not going to work in dy land. Okay, so you'd have to get x by itself. What would it be? Square root of y. That's this new boundary. I can't call it y equals. I have to make it x equals. What about this other one? I would add my x across to make it positive, but then what would happen to my y? It would become a minus y. Now, when you integrate, you're using the y values. So how low does my region start? How low is this? Y equals 0. And then how high is it when they cross again?
Or 5, 4.
That's 4. And then who's on the right for that side? The line, which is 6 minus y, minus the curve, which is square root y. So this is the right side of the region. This is the left side of the region. And then 0 and 4 are the places they are at 0 until 4. Does that make sense? Okay. Y'all kind of get it? Yeah? Okay, let me see on the last page if we need to do one of those. Let's do number 6 because it's graphed where you can just count it. Okay, so look at number 6. Okay, this is 1. I even tried to erase it off the thing, but it's okay. Okay, this is -1, -2, 1, and 2. That's your axis. Okay, so for my first double shaded extra dark region here, where would I integrate from? Where to where? What are your y values of your intersections?
Which one?
-1 to 2. This is region R, so that's this top one. Okay, and then who's on the right?
The line.
The line. Now question, is the line in a usable form right now?
No.
I'm going to have to fix it. Who's got to move?
X equals
The -2 is going to move across, so now it's going to be x equals y plus 2. And I'm going to rename that one because it wasn't in a usable form when we got it. Okay, so it'll be at y plus 2 minus y squared. Questions are good. Okay, try to set up your second part. Now you want region S. How are you going to split it up? Vertically or horizontally? Horizontally. Where are you going to split it up at? Where's the cusp? -1. So let's do this bottom part first. Where would I integrate from? What y values?
-2 to -1.
-2 to -1. And on this piece, what function am I touching?
The y.
The y plus 2, the line. Plus, now I'm going to my second pocket. Okay, we can do this one in green. What are my heights that I'm integrating from?
-1 to 0.
-1 to 0. And then which function am I touching there? Y squared dy. Okay, so this one would be an example of a sandwich. And this one would be an example of a cusp. But rather than splitting it up and down, for dy, you have to split it up sideways. Okay? I'm not going to